Okay, hello again, ladies and gentlemen. All right, so here we are for the fifth and final method of proving triangles congruent to each other. Okay, it's called hypotenuse leg, and as the name suggests, the only kind of triangle where we would talk about a hypotenuse is a right triangle. Okay, so this is real easy to explain. It basically boils down to the Pythagorean theorem. If I have this triangle over here and I know that one leg is supposed to right triangle, I know one leg is 3 and the hypotenuse is 5, let's say. Well, we all know what this side's going to be, right? Not going to be 0. It's going to be our old buddy, the 3, 4, 5 right triangle, right? Well, suppose I didn't have that. Okay, I didn't have that side. All I know is that hypotenuse and that leg are congruent in this triangle to this hypotenuse and this leg. Okay, if I have the hypotenuse and the leg of one triangle congruent to the hypotenuse and the leg of another triangle, the two triangles have to be congruent to each other by the Pythagorean theorem. That third leg has to be true. Okay, so that's basically the basis for this one postulate. Okay, it's the Pythagorean theorem. Okay, so since this is only going to be true for right triangles, in other words, the hypotenuse doesn't mean anything in any other kind of triangle. So in order to use the hypotenuse leg, we have to be talking about right triangles. So that is a statement that has to be made within the proof. We have to prove it's a right triangle first, and then we can go on to use the hypotenuse leg postulate. Okay, so I'm going to mark what I have here. BD is perpendicular to AC. Does not say anything about perpendicular bisector. It just says perpendicular. So that's all I can say. Okay, all I can say is that those are right angles. AB is congruent to CB, which is this one. Okay, now based on that and the reflexive postulate, BD is congruent to itself. Okay, well, we have two right triangles, and we have the hypotenuse and leg of one congruent to the hypotenuse and leg of the other. We know they must be congruent triangles. Okay, so this is the way this one has to shape up. Okay, so I'm going to start with the given BD is perpendicular to AC. Okay. Okay, now I have to state that those two angles are right angles. I don't have to state that they're congruent to each other. Remember, this doesn't really involve the angles being congruent to each other. The angles have to be right angles, and that's it. Okay, so I'm going to say angle BDA and angle BDC are right angles. Okay, and that, can I move this whole thing over? Yeah. Okay, that 1, 2 is by definition of perpendicular. Okay, that those things are right angles. Now, in order to use hypotenuse leg, I have to actually declare that triangle BDA, or I'll call it ADB, and triangle CDB are right triangles. Okay, right triangles. I have to actually state that in the proof before I can use hypotenuse leg, because the word hypotenuse doesn't mean anything unless I'm talking about right triangles. Okay, and this is going to be by definition of right triangle. It's a triangle with a right angle in it. And the step before that, we said they were right angles. So then that's it. Okay, now I can go ahead and do my hypotenuse leg proof. Okay, so AB is congruent to CB. Okay, that was given. Okay, that's my hypotenuse. 5. Okay, BD congruent to BD by reflexive. postulate. Okay. And now I'm done. I can say triangle ADB is congruent to triangle CDB. Okay, and I used, put my numbers in here, 5, 6, and I write HL is congruent to HL, hypotenuse leg. It's congruent to hypotenuse leg. Again, the key to this is steps 2 and 3. Step 2 says that I have right angles. Step 3 says I have right triangles. Those two statements have to be in there before you can use hypotenuse leg. Going back to the court case, the court analogy. Okay, suppose I tried to use hypotenuse leg, but I never declared my triangles were right triangles. I object, Your Honor. How can you say there's hypotenuse unless you've established that there's a right triangle? Okay, sustained. Okay, can't say that. So we have to say that the triangles are right triangles first before we can use hypotenuse leg. Okay? Okay, so here's the second one. Okay, AC is perpendicular to BC. So that's going to say this is a right angle in here. Oops. In there. And AC is congruent to DA. So this is a right angle in there. Okay, again, you're not going by the appearance. Maybe they don't look like right angles to you. Okay, but you're going by what you're told. Okay, AB is congruent to CD. And again, by reflexive, okay, that's congruent to itself. So we have the hypotenuse, which is AB and DC, and we have one leg, AC congruent to itself. We've got hypotenuse leg. Okay, so we start the proof. Okay, 1, I'm going to say AC perp to BC, and I'm going to combine those two, AC perp DA. Okay, I can combine them. They basically say the same thing with the same reason. Given. All right. 2. I'm going to say that angle, now I have to use 3 letters here, angle DAC and angle BCA are right angles. Okay. 2. That is by definition of perpendicular. Okay. 3. That makes triangle a DAC and triangle BCA right triangles. Okay, that is 3. It's definition of right triangle. Okay. Now that I've established that they are right triangles, I can go ahead with my hypotenuse leg proof. So AB congruent to CD. That was given. And 5 AC is congruent to AC, congruent to itself. So our old buddy, the reflexive postulate. Okay, and we're pretty much done. 6, triangle DAC is congruent to triangle BCA. 6, HL congruent to HL. Okay, and that's it. Okay, so again, the key to this is stating that the two triangles are right triangles. If that is not in there, you will lose points on a hypotenuse leg proof. You must establish the right angles, which makes the right triangles, and then you're free to go ahead and use hypotenuse leg. If it's not in there, you will lose points. So make sure you've got that order of statements down correctly. Okay, that's it. So a couple of proofs here for you to do for homework, and then submit into the Google Classroom assignment just like you've done the last couple. All right, and that's it. All right, see you next time.